So quadratic functions, we can use regression on them as well. And it's basically the same steps that we did for linear regression, except for when we do the calculation, we want to do quadreg instead of the linreg. So after you enter in the data and then calculate it, let's see, I got rounding to the thousandths. And if you do zoom stat, you can make sure that you have your plot one on and that you type the equation in. Might look something like this. Okay. So it says, use the model to calculate the MPG for a speed of 63 miles per hour. So miles per hour, that is the first list. So these are my x's, these are my y's. So this means that x is equal to 63. So if I want to use the calculator to help me out, I could do the calc value command. So second calc value, and type in 63, and then I get 29.091, and I'm going to round that to the nearest whole number, so 29 mpg. Okay. It says use the model to determine the speed that maximizes the miles per gallon. So this is where I want to find the maximum. So if I go to the calc menu and do calc maximum, I need to choose the left bound and the right bound. So I'm going to choose somewhere to the left of the maximum. Again, what's going on here is you're giving the calculator a window in which to search, and then it'll search that for the maximum. So left bound, press enter. Right bound, press enter, then make a guess, and it's going to be like somewhere here. Okay, and my coordinate is 56.912 and 29.721. Now they want the speed that maximizes the miles per gallon. And speed is our x values, not our y values. So rounded to the nearest whole number, that would be 57 miles per hour. Now again, we're using the model here, and that means we're using our regression model. We're not actually using the data points, and sometimes there's kind of a discrepancy between the two, because if you look at the point here, 55 and 30, there was a car that went 55 and they got a miles per gallon of 30, and that's bigger than our 29.7 and our 56 with the corresponding speed. So the model does not always, I guess, line up with data points. That's because it's an average. But that is what the question is asking for. It's what does our model say, not necessarily what are the real life data points.